Everybody, Daniel here from Basement Tech. Regular watchers of the channel will remember that I'm converting this CNC Shark from its proprietary controller and software to LinuxCNC. So the topic of this video, which is number 5, I believe, in this series, is shielding. So what is shielding and why should you care? Well, shielding is the act of containing electrical noise in the place where you want to keep it, and or preventing electrical noise from getting into places where you don't want it. Side effects from electrical noise can be, random trips of limit switches, all the way up to noise in the radio you have in your shop, all of which can be quite annoying. Well, I have to admit this video does get a bit long, but I urge you to stick with it. In addition to just the discussion about shielding in general, it has a couple fun demonstrations like what does the inside of a G540 look like, and how can a spectrum analyzer help us know if we've actually reduced noise? Okay, so shielding, what is it? Well, it's the things you implement, the pains you go through to contain electrical noise in the place where you want to keep it. Typically that means you want to drain it off into some place where it doesn't matter, and typically that is a ground. Now I'm using that word very loosely here because there are multiple interpretations of ground. You might remember in the beginning I implemented this little terminal strip. That's power supply plus, power supply minus, or ground. Now that ground is absolutely to be distinguished from an earth ground, which is the one you want to use for shielding. So what kind of things do you connect to earth grounds? Well, shields. You might remember my exuberance over these new stepper motor control cables. They were fully shielded, I said, and they have a drain wire which allows you to connect that shield to ground. And I didn't say it at the time, but I meant earth ground. To give you a better idea of that, I have a cable like this, and you can see in the inset up above, it has 3 wires and a foil shield. Now what does that mean? Well, for carrying signals like a limit switch, you need 2 wires. That's these 2 wires, the red and the black. As a matter of fact, the black ends up connected back to the power supply or signal ground. This uninsulated wire runs the length of the wire and connects to the inside, electrically connects to the inside of this foil shield to give you a way to connect that foil shield to earth ground, not power supply ground. So notice the huge point I'm trying to make here, which is your signal carrying wires are distinct and separate from the shield that you're using to contain electrical noise. Again, my fancy new stepper motor cables have a very similar configuration inside, except there are 8 of these wires, 9 of them, for each of the wires in the DB9. So back to what do you connect to what? Well, these wires, typically called drain wires, need to find their way to an earth ground. So what do I mean by earth ground? You're all familiar with earth ground. You've seen these plugs all over your houses, and they have this 3rd prong. The 3rd prong ends up being connected to the 3rd prong on the plug, and that green earth ground wire ends up making its way all the way back to an electrode that's pounded into, you guessed it, Mother Earth, hence the term earth ground. Earth ground is what you want to use for shielding. Signal ground or power supply ground is what you want to use as the return path for signals or the return path for the current that's flowing in your electrical devices. Now I do need to make a note here. There's bonding and grounding that are part of electrical safety. That's the green wires that run all over your house. There are separate theories and implementation details associated with electrical safety grounding and bonding that I'm not talking about here. This is electronic system shielding and power supply grounding. So what do I mean by that? Well, in this system you might notice one addition. It's this. This is my earth ground bus. I'm also going to make a comment here. This is by no means a perfect implementation of an earth ground bus. So what do I have here? This is a ground bus. You maybe can't see it, but all the top screws are connected together, and this green wire ends up back at a metal box in my shop. I mentioned earlier electrical bonding and grounding. If your house is wired properly, any of those metal boxes you have in your basement or metal conduit should go back to a very nice earth ground. So that's what I've done here. This one goes back to a very nice earth ground. One other item worth note is this system is a bit atypical in that I'm keeping it open both so you can see it and also to make it easy to change for experimentation and research purposes. That's atypical, and what's more typical is you would put all of these electronics in a metal box like the original CNC Shark controller, and like you can see sold in many places, a box exactly like this, by the way, exactly size and shape, that has a cutout to accommodate the Gecko G540. That third prong on the plug down there finds its way through the power cord to this prong, and that is typically, and in this case is, connected to the chassis of the machine, making all of that metal an effective shield to contain the electrical noise that's generated by the components within. You might remember also I mentioned at the outset there were all of those drain wires just sticking out, dying to find their way into this fan and jam it up. What I've done since the last video is just put some heat shrink tubing on those, connected all of those drain wires from my limit switch wiring to my nice new earth ground. That enabled the shields in those wires, some of which are 2 or 3 meters long, nice antennas, to drain the electrical noise that's generated by the motors, for example, to this earth ground into a harmless place. Again, not perfect, but probably better than nothing. Now let's move on to my first Gecko G540 disappointment. So I mentioned I bought very nice stepper motor cables that were fully foil shielded, and as a matter of fact they were braid shielded. So out on top of the foil shield was another braid of copper conductors that made essentially a double shielding. All of those found their way back to a drain wire, which I had full intentions of connecting to the shell. By the way, all of the power in the system is off in this case. So those shields typically find their way back to the shell, which finds its way back to the shell of this DB9 connector, which is typically connected to the chassis of electronic devices, which you ground to your earth ground, and that allows the shield then, again, of my 13-foot stepper motor cables, which are honestly generating most of the noise in this system. All of that noise is drained off to this earth ground. So here's my disappointment. The shell of these DB9s are not connected to the chassis of the G540. So let me just demonstrate with this simple continuity meter what I mean by all of this. So this is your typical, and honestly I've had this for decades, Radio Shack volt ohm meter. And when I connect the two wires together, it has a mode where it sounds a beep. This is continuity mode, and it sounds the beep if the resistance is fairly low. So for example, I know the shell, the chassis of the G540 is metallic. So one of my questions was, are these mounting screws providing an adequate connection to the metal of the chassis, because I want to ground that. So if I check these two mounting screws, this is wood, so it's not connecting through the backside. Yeah, that's a good connection from the screws, the mounting screws, to the chassis of the G540. There's nice paint on there, and there may be no, actually there's no unpainted surface for me to test. By the way, painted surfaces will act as insulated surfaces and not provide good grounds. So if you are grounding to a chassis like this, you have to ensure that you have unpainted surfaces. Scratch the paint off, sand it, do something to ensure that you have a good metallic connection, like this. So if the shell and screws of these DB9s were connected to the chassis, then when I touch them, I would also hear the beeping sound. And you're not hearing the beeping sound. So I'm claiming to you that this is very atypical of electronic devices and systems, to have the shell of the connector isolated from the chassis of the device. And that makes it a little bit difficult for me to figure out how then to connect the shield on my motor cables to a good earth ground. So I'm going to have to give it a think, but what I plan on doing is opening these connectors back up, which is very easy, and running the drain wire back out through the back of the connector and connecting that to my good earth ground. I'm going to give that a think, but that's probably what I plan on doing. While I'm doing that thinking, I thought of a couple other tests I wanted to run. I did want to make sure that my suspicion is correct, that the shield of these stepper motor cables is in fact connected all the way through to the connector shells. So how would I do that? 3, 2, 1, think about it. So I'm going to connect one side of my beepy meter here, and yep, lo and behold, that beeps. And I'm going to go all the way out here where I have the other end of this same cable, and if the shell here beeps, yeah, these cables are made properly. The shells of the DB9s connect to the shield and make it all the way through the cable. So that's a good thing. Another thought occurred to me. In the Gecko G540 manual, it says, if you have shielding conductors out at the motor, return them to the Gecko G540 through pins, let's see, 2, 3, and 4, which are said to be grounded. Now, you know, because I'm saying that way, it's going to end up not going to the place I want it. You notice there are 5 wires here, 4 which are the typical stepper motors, and a 5th one which just connects to the chassis of the motor. So, dutifully, I connected that to pin 3. So my question is, does that actually run to power supply ground, or does it run to the chassis in any way, in a way that I might find more useful? So how am I going to test that? Well, I'm going to connect my little electrode to a place that I know is grounded, doubly check it. Yeah, beep beep. So I have put a little stinger on the end here of my meter, and I'm just simply going to stick that into pin 2. No beep 3, no beep 4, no beep. So it's not connected to the chassis. Is it disappointingly connected to the power supply ground? This side over here is power supply ground. Again, warning, all the power is turned off. Are those pins connected to power supply ground? Yep, disappointingly so. Okay, so I'm not going to use those pins. I'm going to find another path for that 5th wire, and I'm going to find a way to get the shield out of this connector and connect it to my good earth ground. Well, while staring at this, trying to figure out how I was going to get a ground, an earth ground, to the shields in my motor cables, I had one idea, which was, could I just back out these little nuts that are used to accept the little securing screws here from the connector, and just put a little ground wire under each one of those. Well, I worried that there might be nuts on the back of those inside the G540. Anyway, I just had to get a look inside of the G540. I happen to have another one around the shop, and again, I know that's a luxury, and wondered what it looked like inside. By the way, there's a really good video put out by Gecko on how to get inside these and do some troubleshooting. So I used that to build some confidence to open up the second one I had. Well, here it is. And that thwarted my effort and threw cold water on that plan. You see those little nuts there, but they're actually just sort of riveted onto the connector shell. Also, you can see this definitely confirms my measurements. There's no connection from that metal shell of the DB9 to anything. It kind of just floats out there in air, you know, on top of the soldered connections to the what Gecko calls the motherboard. So if you haven't seen inside one of these, here you go. There are 4 controllers just stacked up like little soldiers. By the way, they're individually serviceable, and this comes apart in 2 pieces, and the top is called the motherboard, and you can either service or swap out or send back to Gecko the little individual boards to be serviced. So pretty cool. By the way, this Gecko G540 is a bit older. If you happen to have a newer one and you do testing similar to this and have a different outcome, please post that in the comments and let me know. Well, this just keeps getting more and more fun. Well, more and more fun perhaps for me, longer and longer for you. In trying to think about how I can convey the effect of shielding, I thought about using my digital oscilloscope, which you see here. The top trace, all the yellow noise, is what's being picked up by this makeshift antenna that I just connected to one of the inputs. The bottom is what is unique and fascinating. It's actually a display of frequency versus amplitude. This scope has a mode called a FFT, fast Fourier transform, where it converts that time domain noise from the top into the frequency domain at the bottom. Right now I have the motors engaged and the power supply engaged. What I'm going to do next is press the E-stop and see if any of the noise goes away. Pressing the E-stop should turn the motors off, and lo and behold, you see an awful lot of those frequencies disappear on the bottom. And it actually makes sense from a frequency point of view. Total full-scale frequency on the right is about 250 kilohertz. In the middle is about 125. So what you see left there is actually the switching frequency of the power supply. If I turn the power supply off, just to confirm that, yeah, lo and behold, the noise stops moving, and although the peak didn't go away, the fact that it's not moving means it's not acquiring any kind of a signal. Let's see if I can make that, convince you of that. There we go. No signal being acquired at this point. Now, to kind of confirm the inverse, if I turn the power supply back on, lo and behold, that one peak reappears, and that's at a little over, maybe about 100 kilohertz, which is typical switching frequencies for these switching power supplies. So that all holds together. Okay, well, referring back to some of my earlier deliberations on how I was going to get earth ground connected to the shield of these cables, I opted for this choice, which was to take this green wire in the back of the connector and connect it to the drain wire internally that connects to the shield of this cable. So having done that, I got some really fun and interesting early indications that this may help. So again, stating the disclaimer that I'm not going to be making absolute measurements, but relative measurements, I have the following good news. So in this setup, in case it's not obvious, only the Z motor is connected, and only the Z motor currently has that green now drain wire. This again is that spectrum of noise, and the little peaks down near the bottom are the ones that are generated by the Gecko G540 in sending pulses out to the motor. So if I now take this drain wire and just in a very informal way press it onto and remove it from this earth ground, let's see what the effect is on the relative size of those peaks. So here we go, on, off, on, off, on, off. I think you would agree with me that there's a substantial reduction in the amplitude of the noise coming from those peaks. So my claim is going to be that that's a reduction in the emitted noise from the stepper motor cable. Remember, the only connection to that noise is through this antenna. Well, through the magic of video, I've completed all three axes according to the pattern set with the Z-axis, and I have seen the expected improvement. In addition, I gave this a try for connecting that shield wire to a place that has a earth ground connection through the shield of the stepper motor cable. Now I obviously have more to go as I pan back and you can see these bare unshielded wires hanging out there in open air just radiating away. But I think this is a good start to contain the electrical noise where I want it to be. Okay, this one got a little long, so I think a summary is in order. So what did we learn? Well, while I won't claim that shielding will prevent your CNC router from cutting wood, I will claim that it will help with annoying behaviors. Therefore, using shielded cables for limit switches and motors is important. We talked a lot about the difference between power supply ground and earth ground. Therefore, connect your drain wires to earth ground for the best possible shielding. In investigating the Gecko G540, we discovered that its DB9 motor connector shields are not connected to its chassis. My message here is just confirm that what you think is connected to ground is. Secondly, I hope you've understood through this video that shielding is a system of implementation details. No shielding will be perfect, but by combining a lot of different things like shielded wires, good earth ground, and metal chassis, you can effect a good shielding system that will positively impact the operation of your system. Finally, I'll make this note again. Shielding is different than electrical safety. If you like this video, this particularly detailed video, please give it a thumbs up. I urge you to ask your questions and put in the comments experiences that you might have had along these lines. Also, suggestions and debates about the results are more than welcome. Please subscribe to the channel to see more videos like this, and give the notify me when I see extra videos appear button a push. Thanks, and talk to you next time.